Go.
So geometric mean theorems. Remember, geometric mean is when you're multiplying cross products and the opposite sides have the same value. So we're using that idea to apply it. I want you to understand what this means. So this big red triangle, it says that when I draw an altitude, it creates 3 similar triangles. So quick review, altitude means that you start at a vertex and you end at 90 degrees on the opposite side. So the big red triangle has an altitude drawn from vertex C to the opposite side, which is point D. By drawing that altitude, we create 3 similar triangles. I have this little green one, I have the medium orange one, and then I have the large red one. So I took those 3 triangles and I changed it to the same orientation so you can see what lines up. So that's what's down here. I have the small green, the medium orange, and the large red. The reason why I did that is if you remember back when we were talking about similar shapes, you have to have corresponding parts. So the corresponding parts would be the same location, so to speak. So the small green triangle has a hypotenuse of CB. The medium has a hypotenuse of AC. The large one has a hypotenuse of AB. We also have 2 legs. We have a short leg and we have a long leg. So if I were to set up a proportion, I could say short leg over long leg, short leg over long leg. By looking at it this way, it's a little easier than trying to say short leg over long leg up here using those 3 triangles. That's why I drew it this way. But this is the basis of the 2 theorems that we're going to talk about today. So this altitude creates 3 similar triangles, and we can use corresponding parts to find unknowns. That's what it comes down to. So this geometric mean theorem, we have 2. This one specifically talks about the altitude. So this big black triangle, ABC, I have this teal line drawn. That teal line is my altitude. I'm going to use this theorem to find that altitude. This red is the y, and this is what I talked about a few minutes ago. So I took this little triangle, CDB, this little one here, and redrew it, and the medium one, ADC, and redrew it. The reason why I redrew it is so you guys can see where the pieces are coming from. So from here, I did BD over DC. That's short leg over long leg. Over here, DC over AD, short leg over long leg. That's kind of proper proportion procedures. From here, look what happens. This cross product is DC squared. This cross product is BD times AD. When I square root both of these sides, DC is by itself, and then we have that geometric mean idea that we talked about a few minutes ago and a couple chapters ago. So this is where this teal comes from. If this makes sense and you're able to see these triangles with the corresponding parts, that's great. I think for a lot of you that's confusing. So this is the Miss Pritz as simplified as I can get formula. This is not what's in your book. So I hope that this is going to simplify it enough for you. So altitude, that's this teal line, equals, it's the geometric mean of the 2 hypotenuse pieces. The way I have this written is hypotenuse segment 1 times hypotenuse segment 2, and then square root it. What I mean by that is hypotenuse segment 1, hypotenuse segment 2. This is the entire hypotenuse. It's made up of 2 pieces. You guys see that? It's as simplified as I can make it. To find the altitude, you multiply the 2 pieces of the hypotenuse together and square root them. So this is simplified. This is the why it works. Let's look at the first example. So it shouldn't be a shocker that this first example we're using what I just explained, but understand why. The altitude is what we're shown as missing, so we know that this is an altitude kind of problem. We're going to use this idea here. The altitude is x equals the square root of the 2 hypotenuse segments. Look at my picture. These are the 2 pieces that I need. What's this length?
5.
Good, I hope you guys see this. If this is 20 and this is 15, this must be 5. So the two hypotenuse pieces are 5 and 15. So I hope you see how this directly relates to this. This is how we got it. 5 times 15, what does that give me? From here, I want to practice simplest radical form. What's the perfect square under there?
25.
Hopefully that jumps out at you. So we can break this down into 25 times 3 because 25 is a perfect square. So simplest radical would be 5 square root of 3. Can anybody tell me what this is as a decimal? Because I want to do it both ways. 5 square root of 3, or you can get up and move if you can't see, that's fine. Can someone do square root of 75 on a calculator for me? Then round to the tens place.
8.7.
Thank you. So either of these answers will work. In the book, I'm not sure if they ask you for a decimal or simplest radical, but this is good practice to get into. Questions so far? Okay, let's move to another example. So example 2, I hope you see that this is a very similar problem that the one we just did. A little more complicated because we have an expression rather than just x. We're going to set this up the same way. So look at what's given to us. I have an altitude and 2 pieces that make up the hypotenuse. That tells me that I'm using that altitude formula that I talked about a minute ago. So that altitude formula says altitude, which is the x plus 9, equals the geometric mean of the 2 pieces that make up the hypotenuse. That's 8 and 18. It's set up the same way as the last one, but we have to solve it a little differently. Questions so far? Okay. So in this case, I'm going to simplify over here. What's 8 times 18? So I multiply just to see if I can get anywhere by just multiplying. And I did. So this is actually pretty easy. What's the square root of 144? Wow, look how easy this is. So what's my x value?
3.
Good. I subtract 9, so x is 3. So this one looks kind of nasty, but once you multiply and start simplifying, it's not as bad as it looks. So our goal was to find x. We used our geometric mean theorem idea to find that x is 3. Questions on that one? Look at the next one. Again, we know we can use the geometric mean altitude idea because we have altitude and we have the 2 pieces for the hypotenuse. Set this up with the same idea. Altitude equals the geometric mean of the 2 pieces that make up the hypotenuse. So 12 is the geometric mean of x and 8. This one looks a little different. So in order for us to get x by itself, what do you think our first step is going to be? What do you think the next step's going to be?
Square it.
You're absolutely right. There's nothing else to do. In order to get this x out of here, remember basic equation solving, I have to get rid of this 8 and I have to get rid of that square root. I can't pull that 8 out of there until I get rid of the square root. So my first step for this one is to square both sides. I'm going to square this side and I'm going to square this side. Squaring this side so I can get rid of that square root. Squaring this side to keep my equation balanced. 12 squared gives me 144. And on the other side, we've talked quite a bit about how a square and a square root cancel each other out. So on the right side, I have 8x. Now all we got to do is divide. What's x? Okay, so those were 3 examples using our altitude geometric mean theorem. Questions so far before I move on? Okay, so this one is different. So the last one, we were looking for this CD, this altitude. For this theorem, we're either looking for the long leg or the short leg of the biggest triangle. So first of all, I want you to see that there are 2 legs that make up that big triangle. We have a short leg and a long leg. You see that? Short leg is CB, long leg is CA. So this is one way to look at it. This is the simplest way I can teach you. So to find this leg, this blue leg, the long leg, you're gonna do the geometric mean of the entire hypotenuse and the part of the hypotenuse touching the leg. Remember, that's Miss Pritz's words. What I mean by that is this leg is the geometric mean of the entire hypotenuse and the part of the hypotenuse touching the leg. This is the part that's touching this leg. Okay, now let's look at the other side because we have two scenarios here. This short leg is the geometric mean of the entire hypotenuse and the part of the hypotenuse touching that leg. Do you guys see both scenarios? So this is the part that's touching this leg. This is the part that's touching this leg. They're similar scenarios, but you have to pick the correct part. Okay, let's look at an example. So the first example, I want you to see how this one's set up differently. They don't give you an altitude. We're talking about a leg. So this is a leg scenario. We're going to use this black formula, so to speak, to set this up. This is the leg we're talking about. So x equals the entire hypotenuse. What is the entire hypotenuse from here to here? What is that number? 20. Good. And what part of the hypotenuse, what number do I put in for the part of the hypotenuse touching the leg? Good. This is the part that's touching this leg. So for this one, we just need to multiply and square root. This is basic geometric mean that you did a couple chapters ago. What's 20 times 9? Simplest radical. What's the perfect square factor that goes into 180? What's the perfect square that goes into 180? 36? Does that go into 180 evenly? Okay, 36 times 5. I was hoping you guys would tell me 9, because 9 jumps out at me. 36 doesn't. For you, that's good. But 9 would have worked. You would have just had to do it twice. So 36 times 5. 36 goes in evenly. We broke it down because 36 is a perfect square. When we square root 36, we get 6 on the outside. The 5 stays on the inside. This is simplest radical because we have no perfect square radical. Let me try that again. This is simplest radical because there's no perfect square factors under the radical. Can someone give me the answer in decimal form? Square root of 180 rounded to the tens place. Anyone have that for me? Go ahead. 13.4. So 6 square root of 5 or 13.4. Look at the next one. Again, this is another leg kind of problem. We have a leg and we have hypotenuse information. There's nothing given to us about the hypotenuse. So this one is a leg kind of problem. This leg is equal to the entire hypotenuse, which is 12, and the part of the hypotenuse touching that leg, which is A. Similar setup, entire hypotenuse and the part that's touching it. What's my first step in solving this?
Squaring it.
Good. We're going to square this side, and we're going to square this side to keep our equation equal. On the left, we have 36. On the right, remember the square and the square root cancel out, so I get 12a on the right. So what's a? 3. Divide both sides by 12. A is 3. Okay, the next one is a little bit tricky. Stay with me. So again, we have a leg kind of problem because we have a leg and we have hypotenuse information given to me. So let's start by setting this up. The leg is y plus 1. I need the entire hypotenuse from here to here. What is that? I couldn't hear.
3y minus 1.
Good job. So we have to add these two things together. Y minus 1 plus 2y. Combining like terms, this is really 3y minus 1. That's the entire length. So my entire hypotenuse is 3y minus 1. What's the part of the hypotenuse touching the leg? Good. So even though this one looks different and looks like it might be harder, go through the steps. It's the same steps as we've been doing. So what do you think my first step is going to be to solve this? Give me a wild guess. Square. So let's get rid of this radical. So I'm going to square this side to get rid of that radical. Whatever I do on one side, I must do on the other. So nothing really new so far. On this side, you have to FOIL it. You cannot just take that exponent and apply it to this because of that plus sign. Because of that plus sign, you have to FOIL. So again, quick algebra review. FOIL means first, outer, inner, and last. That's how you multiply two binomials. So first means y times y. What does that give me? Y squared. Good. You guys are doing better in my other classes. Y times 1? Did I hear 1? Y. Good. I think I misheard you. So my first was y times y squared. My outers, y times 1 is y. My inners, 1 times y is y. And my last, 1 times 1 is 1. So most, I can't say most, a lot of FOILing problems, you can simplify those two middle terms because they have the common terms. So what's y plus y? 2y, you're multiplying. When you add, you just add the coefficients. So this simplifies to y squared plus 2y plus 1. So we simplified, or we FOILed and simplified. When I multiply y plus 1 times y plus 1, I get y squared plus 2y plus 1. That's what I just did and just erased. On this side, the square and the square root cancel out. So what I have left is the 3y minus 1 and the y minus 1. I don't want to do too much at once. So now over here, I have to square. So I'm sorry, I have to FOIL it to get rid of the parentheses. So I'm going to do the same thing I did over here. Let's bring down my y squared plus 2y plus 1. Let's use this FOIL idea again. So first, what's 3y times y? 3y squared, good. Because 3 times 1 is 3, y times y is y squared. That's my first. How about my outer? 3y times negative 1? Negative 3y, good. That's my outers. Inner, negative 1 times y? Negative 1. And last, negative 1 times negative 1? 1. Positive 1. Same scenario as last time. These two middle terms can be combined because they have common terms. So what's negative 3y minus y? Negative 4y. Good. I'm just saving myself some room on the board. Okay, in algebra, anytime you see that you have exponents still here, we're going to put everything on one side because it could be a factoring kind of problem. So I'm going to move all of this over here. So when I subtract y squared and move it over here, what's 3y squared minus y squared? What does that give me? y squared minus y squared. 2y squared. I'm going to move this 2y over by subtracting. So negative 4y minus 2y. And let's move this 1 over. What's 1 minus 1?
0.
It's gone. So I moved everything over. There's nothing over here now. Next thing I'm going to do is pull apart any common factors. So let's talk about this in two separate steps. What number do they have in common? These two terms, what number do they have in common? They're both multiples of 2. How many y's do they have in common? There's one y that they both have in common. So what I did was I divided out a 2y. So I'm kind of undistributive propertying it. I know that's not proper English. What did you say?
You're factoring it.
You're factoring, exactly. You're factoring by taking something out that they have in common. So 2y times what would give me 2y squared? Y. 2y times what would give you negative 6y? Negative 3. Good job, guys. So now I have two factors, or two terms. So what I'm going to do is take each of those and set them equal to 0, and I'm going to get two answers. So in this scenario, what's my y answer? Because I divide by 2, y is 0. What's my answer over here? Y equals 3. So these are proper answers to this problem. However, this is an application. This is geometry. So we have to take this a step further. When I put 0 in here, does that make sense? Why? Julie?
It'll be 0.
Exactly. We can't have a 0 distance. 2 times 0 would be 0. You can't have a 0 distance. What about here? This would be negative. You can't have a negative distance. So because of that, we throw this answer away. This answer works for this problem, but it doesn't work for this application. How about 3? When I plug it in here, does it work? Does it work here? Does it work here? Absolutely. So y equals 3 is our answer. Any questions on this one? Okay. Copy down your homework and get started on your homework for me, and of course I'll help you with anything you're not sure about. Two quick add-ons. Number 24 and 25. The directions are more extensive. All I want you to do for 24 and 25 is verify that it's a right triangle. Also, next time I see you on Tuesday, I'm asking you to bring in 2 pennies and a piece of cardboard. That cardboard does not need to be any bigger than a sheet of paper. So we're going to be putting together those clinometers next time I see you on Tuesday. Again, 2 pennies and a piece of cardboard. It can be cardboard, it can be like a cereal box, anything that's going to be hard enough that we can tape or glue that protractor to, and we can put our clinometers together.